Hey, quick note before we jump in today.
The Math is Figureoutable Challenge is open for registration, and we are diving into fractions, May 13th through the 15th.
If you want students to really understand fractions,
instead of just memorizing steps, this is for you.
Head to mathisfigureoutable.com/challenge to register now.
All right, on to the episode. Hey, fellow mathers, welcome to the podcast where math is figure-outable. I'm Pam, a former mimicker turned mather.
And I'm Kim, a reasoner who now knows how to share her thinking with others. At Math is Figureoutable, we are on a mission to improve math teaching.
Y'all, we know that algorithms are amazing historic achievements, but they are not good teaching tools because mimicking step-by-step procedures can actually trap students into using less sophisticated reasoning than the problems are intended to develop.
In this podcast, we help you teach mathing, building relationships with your students and grappling with mathematical relationships.
We invite you to join us to make math more figure-outable.
Hello, hello.
Hey, what's up today?
Well, I'm super excited because I get to go see classrooms today.
Oh,
but we gotta record first.
That is your fave. All right, so let's get these recorded so then you can, you're on today. That's a lot to do in a day. Okay, cool.
Good.
So you might know, not you, Kim, everyone else, that
I might know too.
Well, I think you do know. Put a might in there. But on social media, on Tuesdays and Thursdays, I put out a thing that I've just kind of made it my own hashtag, because why not? Hashtag try this Tuesday or hashtag try this Thursday. And we just started putting out things that are like problem strings or things you can try in your classroom. Relational thinking, as close as it gets. Factor puzzles, like some of our favorite kind of, some of them are quicker. In fact, most of them are quicker, but the problem strings are, definitely longer. And then you could just give those a go. You're like, what should I do today? You could just go look up the hashtag, try this Tuesday or try this Thursday, or on a Tuesday or Thursday, you could see what I posted and you could try those things. So I posted one not too long ago, and I thought that we would do that one on the podcast today. It's kind of become a favorite. And I think, was this your idea, Courtney's idea? I don't remember whose idea this was to begin with.
I don't know.
Somebody cool came up with this idea, and it's not in lessons and activities for building powerful numeracy. So middle school teachers, if you've got that book and you're using it or even grade four. Look, I was in Korea lately, 4th or 5th grade. Then you could totally add this to your repertoire of fraction problem strings. It's pretty cool. All right, so ready, Kim?
Yep.
What is 1/4 of 8?
Oh, 2.
And how do you know?
If you split 8 into 4 chunks, then there's going to be 2 in each one.
Nice. So 1/4 of 8 is 2. Cool.
Yeah.
What about 3/1/4 of 8?
Okay, that's 6.
Because
if 1/4 is 2, then you have 3 of those 2s, because 3/1/4, and so that's 6.
I wrote the second problem directly underneath the first problem, and I scaled from the 1/4 to the 3/4. I just have this kind of arrow, and I wrote times 3, and then from the 2 to the 6, I wrote times 3. It's almost like, almost feels kind of ratio table-ish a little bit. Okay, cool. In fact, I could have written this in a ratio table. That's interesting. I might go back and think about that in a minute. Next problem. What if I were to ask you instead for 1/4, so back to 1/4, but this time of 8/9? What are you thinking about that?
I'm going to call that 2/9. Because I know that 2/9 and 2/9 and 2/9 and 2/9 is 8/9. It's kind of like the 4 2s make 8. Then the 4 2/9 make 8/9.
So I actually kind of wrote 2/9 plus 2/9 plus 2/9 plus 2/9. I'm actually writing it right now. And so that's like 4 2/9. And you're saying that's 8/9. And so
it's also,
go ahead.
It's also related to the first problem. Because instead of 1/4 of 8, this was 8/9. So like if you said something about scaling, if I divided the 8 by 9, then I could divide the 2 by 9. So
very nice. Yeah. One other way I might say that back to you is, so if you know 1/4 of 8 things, is two things. You could kind of say it that way in the first problem. Like if I said, what's a fourth of 8 pizzas? You could say it's 2 pizzas. And in the last problem, what's 1/4 of 8 1/9? You could say, well, it's going to be 2 of those 1/9, 2 ninths. A couple different ways of thinking about that. Nice. Cool. Next problem. What about 3/4 or 3 1/4 of 8 ninths? I really wish our listeners right now could see all the problems. Y'all, you might pause right now and just write down 1/4 of 8 is 2, 3/4 of 8 is 6, 1/4 of 8 ninths is 2 ninths, 3/4 of 8 ninths. Sorry to interrupt, Kim.
I could do 1/4 of 8 ninths was 2 ninths. So I could scale times 3 from the 1/4 to the 3/4.
So I've got
and
those
scale
scaling errors.
times 3 from 2 ninths to 6 ninths.
Nice.
Do you want another way?
Do you have another way?
Yeah.
You're like, of course.
From the second problem, we have 3/4 of 8 is 6. So if I don't want 8, I want 8 ninths. Then I can divide the 8 by 9 and divide the 6 by 9. So now I have 6 ninths.
Nice. And another way I could say that is if you know 3/4 of 8 things is 6 things, you can think of about 3/4 of 8 1/9 as how did I just say it? As six of those 1/9. Woo! Okay, cool. Next problem. Nicely done. Great connections. I like how you sort of used both of the kind of problems before in different ways to think about that last problem. What about changing tax completely? What about 1/5 of 10?
Also 2.
Oh, I wonder if I did that on purpose. I might have to think about that. I don't think I meant it to be the same as the first problem. 1/4 of 8 is 2. 1/5 of 10 is 2. I have to think about that. All right. So 1/5 of 10 is 2. How about 1/5 of 10 elevenths?
That would be 2 elevenths.
Pretty sure?
Yep.
Because
if I cut up 10 elevenths into 5 pieces, that's 2 elevenths for each of the 5 chunks.
Oh, nice.
Or I could say the previous problem just said 1/5 of 10 was 2, but now I have 10 somethings, which would give me 2 somethings, and the somethings are elevenths.
Nice. So 1/5 of 10 elevenths is 2 elevenths. Cool. I like it. Next problem. How about 2 1/5 of 10?
That's going to be 4.
Okay.
If 1/5 of 10 is 2, then 2 1/5 is going to be worth 4.
Like double that. So I'm doing that, doubling the scaling arrows again from the 1/5 to the 2/5 is times 2, and the 2 to the 4 is times 2. Teachers, the reason that I narrate that is so that you can kind of think about, especially if you're writing these problems as we're doing them, you could say, oh, okay, so when a student says that, Pam's suggesting that you would do the same thing, that you would scale from the 1/5 to the 2/5 times 2, scale from the 2 to the 4 times 2. Cool. Last problem. I might actually at this point say, anybody want to guess the next problem? It is 2/5 of 10 elevenths. I wonder if there's anything out there that could help you. I don't know.
I'm going to go from the second problem in this chunk of 4. And I know that 1/5 of 10 elevenths was 2 elevenths. So I'm going to double that, because now you're asking me about 2 1/5 of 10 elevenths, and I'm going to get 4 elevenths.
Nice. I like it. That's probably it, right?
The third problem has 2/5 of 10 was 4. So now if you're asking me about 2/5 of 10 somethings, then I'm going to have 4 somethings, and the somethings are elevenths, so 4 elevenths.
Woo! Nicely done. Kim, are you suggesting that if somebody walking down the street has to find 2/5 of 10 elevenths, that they could actually say to themselves, well, I know what 1/5 of 10 elevenths is, so I can scale that, double it to get 2 1/5 of 10 elevenths. Or they could say, well, I know what 2/5 of 10 is, so then I could just find 2/5 of 10 elevenths, and that'd be 4 elevenths. Like you're suggesting that somebody could actually approach 3/4 of 8 ninths by reasoning. They can actually think about that problem.
Yeah. And they have choices.
Yeah, and they have choices to
Yeah.
kind of have a couple different ways to go.
Yeah. Yeah.
I find it noteworthy that, well, I'm going to guess here. Tell me if you think maybe I'm crazy, but I wonder if there might be a teacher or two out there that's like, yeah, but that worked for these problems.
Oh,
Like,
sure.
that's
Sure.
not generalizable. Like, you're not going to be able to do that for crazy numbers. That the fact that you could find fifths of 10 or fourths of 8 had everything to do with the fact that you could reason through these problems. What do we say to that, Kim?
I think the more experience that we give students, the more that they can start looking for relationships that they own. And I think that if we give them varieties of opportunities, thinking about, so one of the things that we did here was scaling.
Mm-hmm.
So if they know how to scale, that's a fantastic strategy. We also talked about the 2/5 of 10. So if they're thinking about a unit fraction and then they can scale, then they can think about what does a fraction even mean. So 10 elevenths was the one that we
Mm-hmm.
landed on.
Yeah.
Yeah. So I think it's really easy to say that kids can't until we give them the opportunities to try.
Yeah, and I would add to that, nicely said, that if we are coming at teaching math from a perspective of my job here is to help students get answers,
Mm-hmm.
then I don't blame you for going, Pam, this is only going to get answers to some problems. It's not going
Yeah.
to get answers to like every general crazy fraction problem. But what if our goal in teaching math is actually to build mathematical reasoning and mathematical reasoners? Then the things you just mentioned are not just strategies or techniques or methods that we do that we sure hope kids memorize. Nope. They are actual relationships that kids are owning in their heads, which means they can now reason through them for enough they could for I was going to say for enough problems, but not just that. Like, it's not just that they got answers to these problems, and maybe they won't use these same strategies to get answers to other fraction multiplication questions, but in the process of reasoning through these, they're building a whole lot more than just, can I get an answer to a fraction multiplication question? Y'all, if your goal is to help kids just get answers to fraction multiplication questions, hand them AI. They're done. Like, give them a calculator. They're done. That's not our goal. Our goal is to actually build mathematical reasoning. And so that's another reason why we pulled out both of the strategies that we're pulling out in these strings. Anyway, thanks for letting me just kind of mention that.
Yeah. So
Kim,
we talked about,
yeah.
we did the particular string the way we did it. There was a chunk of four, a chunk of four.
Mm-hmm.
And originally, you and I had talked about, I think when you first wrote this string, it was a chunk of three and a chunk of three.
Mm-hmm. Mm-hmm.
And we thought, oh man, this would be even better because we talk about these things, right? We talk about strings. And I think maybe in social media, you may have even posted a set of three problems, a set of three problems. But
I
we,
exactly did. If you go look at the Try This Tuesday that I posted this one, it will be missing a problem out of each of those sets.
yeah. So we were like, hey, let's add to this problem string so that both of those nice strategies come out.
Mm-hmm.
And so when we were tinkering with it, it was so funny because we both started talking about a way that you could make a change, but we made a change in a different way. So
Yeah.
can we talk about that for a second? When
Yeah.
you wanted to add to the problem string, we did it the way that we just did. We did 1/4 of 8, 3/4 of 8, so you could scale. And then we went back and did 1/4 of 8/9. So you then added the 8/9 portion into it, and then you scaled up again to 3/4 of 8/9. So that was the four chunk. And then in the second four chunk, you said, now let's switch that. Let's do 1/5 of 10, 1/5 of 10 elevenths. So it's kind of, you took it to fractions first, but stayed with the 1/5.
Yep.
And then you
Yep.
moved on to 2/5 of 10, 2/5 of 10 elevenths.
Then the scaling. Uh-huh.
Mm-hmm. And the suggestion that I made was to say, let's not have four problems in each of those chunks. Let's do three problems, but let's do 1/4 of 8, 3/4 of 8, 3/4 of 8/9. And then in the second chunk, let's do 1/5 of 10, 1/5 of 10 elevenths, 2/5 of 10 elevenths. So a little bit of a variety where you don't have all four problems in each of those. And we decided that both of those would work. And it's just we had different preferences.
Yeah,
I
and if
think
I
you
can
liked yours
describe,
better.
well, if I can describe yours was a little bit one of the pair the not pairs one of the chunks of three problems
Uh-huh.
sort of focused on one strategy,
Uh-huh.
and the second the second chunk of problems
Uh-huh.
focused on the other strategy. And then
Uh-huh.
Kim, I didn't actually even finish the string
Yeah.
because after when we got down to the 2/5 of 10 11ths, I forgot that there was the last problem, which is kind of just then a clunker. Now we don't give you any helpers.
Yeah.
So for my string where I had the four problems that did both strategies, four problems that did both strategies. Now when I give you the last problem, 2/3 of 6/7, now you could kind of look up and go, huh, let's see, we had two strategies happening in each of these in a different order. What can I use? In your problem string, you kind of did a chunk of problems where it was one strategy, then a
Yep.
chunk of problems where it was another strategy, and
Yep.
then you gave the same help or same clunker problem and said, which of those two?
Yeah.
And I think what we're saying, and maybe I'm just repeating, sorry, that you could do both and probably should. Like
Yeah.
one day do one form and one day do the other, and give kid don't be too predictable,
Yeah.
right? Like too
Yeah, for
predictable.
sure.
No, everybody gets bored when it's too predictable.
Yep.
I'll tell you why I like mine a little bit. Uh, Not that I don't like yours, and I do want us to use both. I like mine because there's this sense of how do I even describe it? Because using either of them for the fourth problem in the first chunk and then switching it up, just I don't know, has the opportunity to kind of keep kids on their toes a little bit.
I like yours for the first way, the first time, the first experience, because they get a higher dose. So I do like that you switch
Mm,
the order, but they get one opportunity to see it in two strategies in the first set, a
hmm
second opportunity to see it both strategies in the second set, and then they get to use it in the clunker. And then the next day or
mm.
2 days later, I'd come back with my version where they still are reminded of the two strategies, but maybe a little bit less often.
Interesting. Okay, I like it.
Are we solving the clunker or no? Maybe we
Oh,
should leave it. We should leave it for our listeners, and then they can reply with which
oh, I
strategy do they
love it.
like better.
Yeah. So go find this one on social media and reply to that post, or just reply, just send out a try this Tuesday. Just use the hashtag try this Tuesday and say, hey, here's how I did 2/3 of 6/7, and we'll check it out. We'll see what you were thinking. How are you thinking about 2/1/3 of 6/1/7? Like which of those two strategies that we were kind of throwing out today are you thinking about? Or tell us your own strategy.
Yeah.
All right, y'all. So check out social media. Try this Tuesday, try this Thursday for great use right away problems for your class. Can I point out one other thing, Kim? Point out
Yeah.
one other thing. I hope today we also modeled that we're all about continuing to improve our craft. Like
Yeah.
you said, Pam, but you've already put this out one way. How dare you put out another, like how dare you fix it? So just, you didn't say it that way, but just so we're really clear, if we figure out that something we've been doing, we could do even a little better, we then do that. We're not, sometimes so academics can be a little bit like, ooh, I've already written it that way. I don't want to look stupid by putting out or inconsistent by putting out something different. We'd rather put out the better as we go. I've actually just found something that I had published, and I'm like, huh, I've changed my tune on that. Like I've learned more. I have a better way to kind of help everybody understand that. So we're all about working together to improve our craft. Notice that we're sort of sharing what you're thinking, what I'm thinking. And when we do that, we're really helping each other improve our math content for teaching. That is the field that is not filled out enough. We have a lot of math, but we don't have enough math content for teaching. All right, y'all. Thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. That's a wrap for today. Want to keep going?
The Math is Figureoutable Challenge is open right now, happening May 13th through 15th.
Y'all, we are focusing on fractions in ways that actually make sense and get success.
Go to mathisfigureoutable.com/challenge to save your spot.
Y'all, that's mathisfigureoutable.com/challenge. We will see you there. Thanks for making math figure outable.